Hello everyone, this is Amir here with another question from Craig's Mechanics of Materials or Solid Mechanics. Before I start solving this question, I would like to ask you guys to support us by subscribing to the channel. Okay, let's read this question. Here you can see a 3-bar pin jointed truss. Support C is a roller support. Support A here is a pin support. A horizontal load P is applied to point B. The maximum load that can be applied to this point is 50 kilonewton. The allowable stress in tension and in compression for each member is given to us. For tension is 140 megapascal and for compression is minus 85 megapascal. And now the question wants us to determine the cross-sectional areas of each member. Okay, I'm going to start by drawing this truss again. So we have a member here, another member here, and this is a third member. Here's our pin support A, here's our roller support C, and this is our horizontal load, which is 50 kN at point B. This is 1200, and this height is 600, and this is 450. So we have AY here and AX here, and we have CY here. So we're going to start by writing the equations of equilibrium. We're going to take the moments around point A, sigma MA is equal to 0 in this direction. So 50, this load, multiplied by this distance, which is 600, minus CY, this distance is 1200, is equal to 0. And this will give us a CY equal to 25 kN. In the x direction, they only have AX and that 50 kilonewton load. So sigma Fx is equal to 0 in this direction. 50 plus AX is equal to 0. And this will give us an AX equal to minus 50 in this direction, or AX is equal to 50 kN in the opposite direction. So I'm going to substitute these values, 25 and this was 50. In the y direction, sigma Fy is equal to 0. So AY plus 25 is equal to 0. So AY is minus 25 in this direction, or AY is 25 kN, but in this direction. So 25. Now for joint C, this is FBC, this is FAC, and this is 25, and this is joint C. So if we call this angle alpha, this is alpha, In the y direction, we can write sigma Fy is equal to 0. So 25 plus FBC sine of alpha is equal to 0. And we know sine of alpha would be, so if we consider this triangle, sine of alpha would be this height divided by length of BC. So we know this is 450. So this would be 750. And we know this height is also 600. So the length of BC would be 750 in the power of 2 plus 600 in the power of 2, which is approximately equal to 960.469 millimeters. And sine of alpha would be this height, which is 600 divided by 960.469. So if we put this value here, we can say FBC is equal to negative 25 divided by this value, 600 divided by 960.469. So FBC would approximately be equal to minus 40.02 kN. And now in the x direction, we can say sigma Fx is equal to 0 in this direction. So minus FAC minus FBC cosine of alpha is equal to 0. So FAC would be minus FBC cosine of alpha. And we know cosine of alpha is this length, which is 750 divided by this length, 960.469. So now that we have the value of FBC and we have the value of cosine of alpha, the value of FAC equal to 31.25 kN. So this was in compression because we used the negative sign, and this is in tension. Okay, now if we consider joint A, we have a force here, which is FAB. We have 31.25. We have 50 this direction, and we have 25 this direction. This is joint A. So if we write the equations of equilibrium in either y or x direction, we can determine the value of FAB. Sigma Fy is equal to 0 in this direction. So if we call this angle beta, this will be our beta. We have FAB sine of beta minus 25 is equal to 0. And sine of beta would be this length divided by this length if we consider this triangle. So in order to determine length of AB, we can write square root of this length, which is 450 in the power of 2 plus 600 in the power of 2, which will be 750 millimeters. And sine of alpha would be 600 divided by 750, which is 0.8. Here FAB would be 25 divided by sine of beta, or 0.8, which gives us an FAB equal to 31.25 kN. So this will also be 31.25. Okay, in the question, the allowable tensile stress is given to us, which is 140 megapascal, and the allowable compressive strength is negative 85 megapascal. So members AC and AB are in tension, so we're going to use this condition. And member BC is in compression, so we're going to use this. So for AC and AB, we're going to use sigma T is 140 megapascal. The loads are the same, FAB and FAC are the same. Both are 31.25 kN. So AB would be equal to AAC equal to FAB sigma T. So this is 31.25 multiplied by 10 in the power of 3 Newton, and this is 140 multiplied by 10 in the power of 6 Pascal. This is equal to 0.223 multiplied by 10 negative 3 square meter. So this is the required area for member AB and AC, which are in tension. And now for member BC, we can follow the same procedure. For member BC, we have sigma C is equal to minus 85 megapascal, and we know FBC is minus 42 kilonewton. So the cross-sectional area for BC would be minus 40.02 multiplied by 10 in the power of 3 Newton divided by minus 85 multiplied by 10 in the power of 6 Pascal. which is approximately equal to 0.471 multiplied by 10 in the power of -3 square meter. So A of BC will be 0.471 multiplied by 10 in the power of -3 square meters. Okay, so these are the cross-sectional areas for each member, and you can see the forces in each member. Thanks for watching this video. Please subscribe to the channel if you haven't already. That's a great way to support us. If you like this video, please press the like button. And if you have any suggestions, feedback, comments, please feel free to write for us in the comment section. Thanks, and see you in the next video.